I'm Dan Reynolds, and I'm a professor in health and environment here at the Department of Biological, Biomedical and Analytical Sciences at the University of the West of England. The work we do here is essentially use microorganisms and bacteria and engineer those bacteria in a way such that when they're alive they emit light, and that process we call bioluminescence. We've pioneered the use of bioluminescence to investigate, if you like, the interaction between novel biocides or novel antimicrobials and bacteria. And what we can show with the techniques that we've developed is the speed of kill. So if we apply a disinfectant to a bacteria, we can watch the lights that are generated by the special bacteria that we make, and we can watch those lights gradually go out. And that's a really useful and powerful way of assessing and understanding how effective these disinfectants are. And the work we've been doing with Centrico and the Toucan system is testing the solutions that have been generated using a very simple electrochemical cell, salt and water, so we've got a very simple means of producing disinfectant, and testing how these solutions interact with bacteria. The video you're about to see shows disinfectants that are produced by the Toucan system. These are called electrochemically activated solutions, and it's showing the effect of these solutions on living bacteria. So when I say living bacteria, most people will be familiar with E. coli or MRSA or Salmonella, those types of things. And what we've managed to show with the research that we've been doing with Centrico is that you can achieve very fast and effective kills of these bacteria by applying these solutions which are produced by the Toucan system. So the video you're seeing, this has been recorded over a 24-hour period, and we use this period to allow any surviving bacteria to multiply and regrow. And if the bacteria that we've tested regrows, then we should see the emergence of light over time, i.e. bacteria recovering after the initial treatment. But what indeed you can see even after 24 hours is that there are no lights present, and you see that in the top row of dishes. This indicates to us as scientists that the Toucan disinfectant has killed all of the bacteria present at the start of the experiment. And what we've shown in the research that we've done is that these solutions are very, very effective. And how effective is effective? Well, in the research that we've done, we've shown that as much as 99.999% of all bacteria that we've applied our disinfectant to have been killed or effectively have been removed. That's a very high kill rate. It's certainly very comparable, if not better performing than other more household names, if you like, within disinfectants. So things like Virkon, alcohol, household bleach. So what we've been able to do with Centrico and the research that we performed here at the University of the West of England is show, using this tool, bioluminescence tool, is show how effective the solutions that are generated from the Toucan system, how effective they are. And we can see this because there's no regrowth. So if there's no regrowth, we know that the disinfectant has worked very, very efficiently indeed. The second thing we know is not only has the solutions generated by the Toucan system prevented regrowth, but they've killed the bacteria in a very short space of time. So they're very fast acting. And with the research that we've done and our experience in working with other common disinfectants, we're very confident that the solutions generated by the Toucan system are comparable, if not better, than many other disinfectants that people commonly use. And I think if you wanted to learn more about the work that we've done here at the university in partnership with Centrico, please download the report.
Agriculture and Agri-Food Canada, the Canadian food industry could soon use a new disinfectant to improve food safety: electrolyzed water. To create electrolyzed water, a special reactor is filled with salt and water. An electric current causes these chemicals to react at the electrodes. This is electrolysis. As the pH level of the solution on one side of the reactor moves from 7 to 2.8, becoming more acidic, disinfecting molecules of hypochlorous acid, chlorine ions, and hydrogen ions form. With these new properties, the water kills or inhibits the growth of a vast range of microorganisms on contact, including germs that lead to food poisoning and even the viruses that cause HIV and hepatitis. Electrolyzed water also eliminates pesticide residues and mycotoxins and reduces germination rate of certain fungal spores. Electrolyzed water also has no adverse impact on the environment. Because it leaves no toxic residue, it can be used to wash fresh foods without affecting taste and quality. Last but not least, this disinfectant is very economical because it must be produced on-site, on demand. This eliminates the costs associated with bottling and transporting. Electrolyzed water could improve the safety and extend the shelf life of fresh pre-cut fruits and vegetables, providing processors with significant savings while helping the food processing industry become more ecological. Simple, isn't it?